Okay, I forgot that when I have the ladybug on, so you can see the notes and stuff, and I go to the moving screen, that kind of overpowers my little MacBook Pro here, and it and it shuts off. Luckily, you got so we're up to 5 minutes of the 45-minute lecture, or 35-minute lecture I was planning here, but we should be good. We should be good. So here's the deal. Here's the deal. So this is time dilation. Now, okay, so if I'm on the proper time, if I'm in the moving ship and I'm in the proper time and I'm cruising along at, say, v is equal to 0.93 c or something like that, all right, for just giggles, then um, let's say I'm going to Alpha Centauri, which is 4.5 light years away. So the proper length measured of Alpha Centauri is 4.5 light years. We do that as a CY for a light year. All right, so that's the distance. And now, don't convert any of this stuff to meters, because it just goes crazy if you do that. So that's the distance measured by a stationary observer on Earth on how far away Alpha Centauri is. Now, if I'm traveling at 0.93 c, then I'm actually traveling at the time that it's going to take me to get there. The observer in the spaceship sees me in a shortened spaceship. My distances are scrunched, are contracted. So the contracted length that I'm going to get there is going to be v times delta t naught. Now, I didn't tell you what that was because I don't know what that is yet. I do know what v is. I do know that L naught is this many light years. Okay, so, and I know what the gamma function is. All right, and I do know this, that L is equal to L naught divided by gamma. All right, so I can figure out what my proper time is using this. Okay, so let's say I'm going 0.93 c. It's 4.5 light years away. All right, it's 4.5 light years away, and 4.5 c. I'm sorry, I'm getting all this straightened out in my head here, and so L is equal to that. So let's figure out what first stop is gamma. So I'm going to figure out my delta t naught at the end. All right. So first step one, find out what gamma is. In this case, since I was given v, I can find gamma relatively easy. The gamma function is equal to 1 over the square root of 1 minus v over c squared. And so we get 1 divided by 1 minus 0.93 squared, because the beta was 0.93 c over c, v over c. So we get 0.93 squared. And luckily, I now have somewhere here on my freaking desk, I know I do, I've got my calculator. Here it is. Got my calculator. So we can do this real simply. Well, with my newfangled calculator, I can do it all in one step. So I get 1 divided by square root of 1 minus 0.93 squared. Close that parentheses, close it again. Boom. Yes, I get 2.72. Okay, there it is. So gamma is equal to 2.72, and so here's the deal. So my L naught, my contracted length, this is contracted length, is equal to the contracted length is equal to 4.5 light years divided by 2.72. Notice, this is unitless. This has no units. So when I take that, so when I do the 1 over times 4.5 here for the light years, I wind up that with my contracted length, I get 1.65 light years. To me, traveling in the ship, it's only 1.65 light years for me to get there. So my time dilation, so the time it takes me to get there, the time it will take me to get there, delta T naught then is equal to the contracted length over the speed. Right? So I've got, now watch this, 1.65 light years divided by 0.93 c. Now look what cancels. Bang, bang. So I'm left with years. Pretty cool, huh? So I'm going to divide. There's my light years. There's my contracted length in light years divided by 0.93. And so it's going to take me 1.78 years to get to Alpha Centauri, as far as my clock's concerned. All right, but the observer on Earth, there we go. So the observer on Earth, delta T is equal to the gamma times delta T naught. Well, I found delta T naught right here, which is 1.78 years. Okay, and so the contracted, so the observer on Earth is going, hey, wait a minute. It should take you gamma, what was my gamma? 2.72, sorry. 2.72 times the 1.78. That's the dilated time that the observer on Earth thinks it should take you to get there. So 1.78 times 2.72, 4.837. Well, let's go 4.838 years. Almost 3 times as long. So you go down and back 3.4 years. Your twin that's left behind, he's aged almost 10 years. Okay, so here you go. Dilated time, delta T, is equal to gamma times delta T naught. And the contracted length is equal to L naught divided by gamma. Okay, now then, and also know this, that the proper length, which is the length measured by the stationary object, is equal to the dilated time times v, or let's do it the way we normally do things, v times delta times the dilated time, and the contracted length is equal to v times the proper time. All right, so you keep those relationships in mind, these 4, and you should be fine with almost any of the questions. Okay, and we'll do one. I'll do one right now. Not now. I'm going to pause, and then we'll get on it.